Hello everyone, in this session we will be discussing about scalar triple product, important one, okay. Problem based on this is important for 3 marks. Let us consider, see, scalar triple product. To define this one we need 3 vectors. Let us consider A vector, B vector and C vector are the 3 vectors, okay. We have considered in plane there are 3 vectors, A vector, B vector and C vector. Scalar triple product of this one is defined as A vector dot B vector cross C vector. I mean it includes both the dot product as well as vector product. Is it clear? A vector dot B vector cross C vector. What do you have to do? First you have to find B vector cross C vector. How to find? Determinant of I cap, j cap, k cap, coefficient of B, then coefficient of C. Then you have to find the determinant. So that you will get one vector here. After that you have to find the dot product of that vector with the A vector. How to find the dot product? You have to multiply the corresponding elements and you have to add it. So this is A vector dot B vector cross C vector is called the scalar triple product. And we will represent this as, see like this, scalar triple product A vector, B vector, C vector. This is a representation for the scalar triple product. Scalar triple product of A vector, B vector, C vector is equal to A vector dot B vector cross C vector. So clear? Remember this important formula. Now can you say is it a scalar product or is it a scalar or a vector? What will get after the multiplication of this? Here you can see this one. This is the one vector, right? That vector with the dot product with the another vector. Dot product will gives you the scalar product, right? So always scalar triple product will gives you a scalar value. Is it clear? We'll get one scalar value. One more thing. Here I have done A vector, B vector, C vector. Can I write this as B vector, C vector, A vector? Is it clear? B vector, C vector, A vector. So this is equal to now B vector dot C vector cross A vector. B vector dot C vector cross A vector. If I write that in the cyclic order, so I will take C here. This is C vector, then A vector, then B vector. Now this will be equal to C vector dot A vector cross B vector. Is it clear? C vector dot A vector cross B vector. Remember all the 3 are equal. You have to take it in the cyclic order. A vector, B vector, C vector will be equal to, the cyclic order means B should be here, C should be here and A should be here. So that is B vector, C vector, A vector. Again take the cyclic order for this one. So this will be C vector, then this is now A vector, this will be B vector. So these will be equal. Now if I consider this as, see, listen carefully, A vector, B vector, C vector. So this is equal to minus of A vector, C vector, B vector. See the difference between these? See, A vector, B vector, C vector. If you take the cyclic order, obviously those will be equal. Here what I did, I have fixed the A vector as it is. Now here B vector, C vector is there, right? See this, B vector, C vector. In this case, this will be A vector dot, right, B vector cross C vector. Here in this case, it will be A vector dot C vector cross B vector. You know that vector cross product is not commutative. So B vector cross C vector is not equal to C vector cross B vector, right? It will be a negative of that. So here what I can write, B vector cross C vector is always equal to negative of this, right? So that's why this is minus of C vector cross B vector. Is it clear? So that's why we can't write directly A vector, B vector, C vector. If you change the cross product order, here B vector cross C vector is there. If you consider C vector cross B vector, those will be negative values. Here you will get one value that is negative of that. See, I write like this is B vector, I will take this is C vector and A. Now this is equal to negative of, so the first element, first vector will be same, that is B vector. Here C vector cross A vector is there, here I can consider A vector C vector. Comma is there. Is it clear? This is about the scalar triple product. And one more thing, to find the scalar triple product, see, we can prove this. Actually proof is not necessary, so directly I tell you. See this one, first what you have to do, as I told you, B vector cross C vector you have to find. So this will be now I cap, J cap, K cap. I'll consider the elements of this one as B1 I cap plus B2 J cap plus B3 K cap. So this is now B1, right? B2, B3. Here I'll get C1, C2, C3. This is dot product with A vector will consider as A1 I cap plus A2 J cap plus A3 K cap, right? First you need to find the determinant of this matrix. After that you have to find the dot product of this matrix. So yeah, this dot product of this one with the A vector. So that you will get one value, that is equal to determinant of A1, A2, A3, okay, B1, B2, B3, C1, C2, C3. You can verify this. Is it clear? So to find the scalar triple product, what you have to do is simple. It is in the first row all the elements of the first vector, second row second vector elements, third row coefficient of I cap, J cap, K cap. Is it clear? So after this simplification, what you get here is A1 into, okay, delete first one, this is B2 C3 minus C2 B3, then minus A2 into, you can verify this, first row this is now B1 into C3 minus B3 into C1, last will be plus A3 into, delete this and this, so B1 C2 minus B2 C1. I hope you understood this one. Actually remember this, no need to prove this one. The thing is you have to remember, to find the scalar triple product you have to take the coefficients of I cap, J cap and K cap. Let me repeat once. See this. To find vector cross product, or first we'll start with the dot product. A vector dot B vector, what you have to do? You have to multiply the coefficient of this and you have to add. That will gives you A vector dot B. To find the cross product, A vector cross B vector will be equal to determinant of I cap, J cap, K cap and a coefficient of this. Those will be A1, A2, A3 and here B1, B2, B3. So this is the vector cross product. Now to find the scalar cross product, so three vectors will be there. A vector dot B vector cross C vector is equal to, just you need to write the elements of, coefficient of these vectors. Since this is a vector, right? Sorry. So this will gives you one scalar, right? So all the values should be there. A1, A2, A3, B1, B2, B3, C1, C2, C3. Is it clear? Dot product, cross product, scalar triple product. Similarly, vector triple product is there, but actually that is not there in your theory concept. While doing the J concept, I'll explain that vector triple product. This is about the scalar triple product. Remember this, okay? Just you need to find the determinant of this matrix. Is it clear? Okay, one more thing. See, if I write this as A vector, okay? A vector, B vector. Now can you see what will be the scalar triple product of this one? See, elements of this I need to write. That will be A1, A2, A3. Coefficient of this will be A1, A2, A3. This will be B1, B2, B3. See here, what about the determinant of this matrix? Here two rows are equal. Whenever two rows are equal, determinant will be equal to 0. So determinant of this matrix will be equal to 0. So whenever same, if you find the scalar triple product of a same matrix, same vector, then the product will be equal to 0. Remember this. In A vector A, or I can consider A vector, B vector, B because the coefficient will be same. So this is also equal to 0. Now one more thing, by using a scalar triple product, you can find a volume of a parallelepiped. Actually proof is there, but it is not necessary. Just remember the formula, okay? And problem based on that is also not there. But remember this, volume of a parallelepiped, volume of a parallelepiped is given by magnitude of the scalar triple product, that is A vector dot B vector cross C vector. So this will gives you a volume of a parallelepiped. You have studied area of a triangle. What is the area of a triangle? Half into magnitude of A vector cross B vector. One more thing, here A vector and B vector should be a adjacent sides, that if it is A, this is B, then this should be C, that is now AB, this is A vector, right? And AC, so this will be B vector. So now if you join these two, this will gives you a area of a triangle. Area of a parallelogram, parallelogram is given by magnitude of A vector cross B vector. Now volume of a parallelepiped is given by magnitude of A vector dot B vector cross C vector. This is about the scalar triple product. Now we will solve some problems. An important concept, coplanarity of three vectors. Let us consider the three vectors A vector, B vector, C vector. They are coplanar. They are coplanar means they lies on a same plane or they are parallel. Then the scalar triple product of that, it is A vector dot B vector cross C vector is always equal to 0. Okay, if it is any three vectors are coplanar, is nothing but they are parallel or they lies on a same plane, then the scalar triple product of this will be equal to 0. Let us prove this one. Actually proof is not necessary, okay, just to remember this formula, it is enough. Now if it is B vector is parallel to C vector, okay, as I told you they are parallel or they lies on a same plane. If it is B vector is parallel to C vector, then the angle between them will be 0. So sin 0 will be 0. So by that I can write B vector cross C vector will be equal to 0, right? So by this what we can write, A vector dot B vector cross C vector will be equal to 0. So while finding the dot product of those, we will get 0. If it is B vector is not parallel to C vector, then obviously B vector cross C vector will be perpendicular to A vector, right? If it is they are parallel, this is a condition. If they are not parallel means obviously B vector cross C vector will be perpendicular to A vector. By this what we can write, A vector dot product of this one dot B vector cross C vector. Since B vector cross C vector is perpendicular to A vector, so angle between them will be 90 degree. Now here we are applying a dot product because cos 90 will be equal to 0. So this is equal to 0. So in the both the case what we can say, if it is any three vectors are coplanar, then remember A vector dot B vector cross C vector will be equal to 0. So problem based on this is important for 3 marks. Okay, just you have to take the scalar triple product of this and you have to prove that is equal to 0. Then if it is equal to 0, then we can say that these three vectors are coplanar. One more thing, see here, if I write distributive law, A vector cross B vectors plus C vector is always holds for a cross product. So we can write this as A vector cross B vector, remember, plus A vector cross C vector. A vector cross B vector plus A vector cross C vector. So if you multiply by any lambda, I mean any scalar, then also this holds. Remember, important for 3 marks. Okay. Remember, 1 mark 1 question will be there, 2 marks 2 questions, and 3 marks 2 questions will be there. Simple chapter. Easily you can score 11 marks in this chapter, as well as for G and CT also. Problem based on this will be easy. Okay. See this. Find a unit vector perpendicular to the vectors A vector plus B vector and A vector minus B vector. There are two vectors are there. See, these are the vectors, right? I'll consider this as sum of those two, A vector plus B vector. Another one is A vector minus B vector. Now we need to find the unit vector which is perpendicular to both A vector plus B vector and A vector minus B vector. What are the possible vectors here? Here two possible vectors are there, right? Two unit vectors we can find. One is along this direction, right? If I take the angle A vector plus B vector to A vector minus B vector. So this is a one unit vector I can consider, right? Another one will be the downwards. If we consider A vector minus B vector cross A vector plus B vector. Is it clear? If I consider A vector plus B vector cross product with A vector minus B vector. So the unit vector will be in this direction. If I consider from here to here, so this is now A vector minus B vector cross A vector plus B vector. So vector will be in the unit vector will be in the opposite direction to this one. Is it clear? So what you have to do to find the unit vector perpendicular to these two vectors, we need to find the cross product of these. Is it clear? Let us find it. I'll consider A vector plus B vector is equal to I cap plus I cap will be 2 I cap, and that is 1 plus 2 will be 3 j cap plus 1 plus 3 will be 4 k cap. Is it clear? We are finding the unit vector perpendicular to these two, not these two vectors, right? So this and this is a vector. Now we will find A vector minus B vector. So this is equal to minus will be 0 plus I minus 2j will be minus j cap, and plus 1 and minus 3 will be minus 2k cap, right? Now we will find the cross product of this. So A vector plus B vector cross product with A vector minus B vector. No need to find both the unit vectors, find any one, okay? Another one will be the negative of that. Directly you can say, actually it is not necessary. So directly write one vector, it is enough. So this is now I cap, j cap, k cap, right? Coefficient of this will be 2, 3, 4. And here 0, minus 1, minus 2. We'll find the vector. So it will be I cap into, delete first row, first column, 3 into minus 2 will be minus 6, minus into minus will be plus 4, minus j cap. I hope you remember this, right? So 2 into minus 4, 2 will be minus 4 and minus 0 plus k cap into, delete this. So 2 into minus 1 will be minus 2, that will be 0. Now minus 6, this will be minus 2 I cap, minus into minus will be plus 4 j cap minus 2 k cap. Let us consider this vector as C vector. Okay, this is a C vector. This vector we go. This is a C vector. But we need to find the unit vector of this one. Actually, this is a vector. Unit vector means the magnitude of that vector should be equal to 1. Right? So for this, what is the unit vector of this? C cap is equal to C vector divided by magnitude of C vector. Right? First we will find magnitude of C vector. What it will be? Root of, see this 2 square will be 4 plus 4 square is 16 plus, what it is? Sorry, 16 plus this is now 4, right? This is equal to now 16 plus 4, 20, 24 root 24. So root 24 can be done as 4 into 6. So 4 into 6 is nothing but we can write 2 root 6, right? So this is now C cap. Unit vector is equal to C vector. We'll write that minus 2 I cap plus 4 j cap minus 2 k cap divided by 2 root 6. So simplify this. 2 and 2 will give cancel, that is minus I cap by root 6 and plus 2 and 2. So this will be now 2 j cap divided by root 6, and this is minus 2 and 2 will get cancelled, k cap divided by root 6. Is it clear? We need to divide each and every term of this one, right? Now this is a one unit vector. Now can you say another unit vector? Negative of that. That means C cap is equal to I cap. Negative of this means it will be plus I cap by root 6 minus 2 j cap by root 6 plus k cap by root 6. Any one unit vector is in. So this should be the final answer. I hope you understood this. Important one for 3 marks. This is also important. Everything is important, okay? find the area of a triangle whose vertices are A, B, C is given. Right? What will be the formula? Half into magnitude of A vector cross magnitude of B vector. For that, first we need to find A vector as well as B vector. First let us draw a triangle. This is not necessary, just draw a rough diagram. A, B, C. If I consider this as A, B, C. So what will be the vector? One is AB vector, I can consider as A vector. Another one is AC vector, right? I can consider as B vector. Is it clear? This should be the point, right? One will be AB vector, another one will be AC vector. So what will be the product? This one half into magnitude of A vector is here, AB vector, clear? Cross, this will be AC vector. You have to start with the same point, AB and AC, or you can go with BA and BC. Like that it should be. AB vector cross AC vector. For that we need to find the AB vector, right? This is also not given. How to AB vector? A vector joining the 2 points, right? AB vector will be equal to A to B, right? 2 minus 1, better you write that. 2 minus 1 I cap plus this is 3 minus 1, 3 minus 1 J cap plus 5 minus 2 K cap. Is it clear? Vector joining 2 points. So 2 minus 1 will be I cap plus 2 J cap plus 5 minus 2 will be 3 K cap. So this will gives you a AB vector. Next we need to find AC vector. AC vector is equal to, see here, A to C. So you have to start with C. So this is now 1 minus 1 I cap plus 5 minus 1 J cap plus 5 minus 2 K cap. I hope you are getting this one. A to B, start with B to subtract this one. A to C, start with C and subtract this one. Okay. Now this is equal to 1 minus 1 will be 0, 5 minus 1 will be 4 J cap and plus 5 minus 2 will be 3 K cap. We got AC vector. Now first we need to find, before finding the magnitude, we have to find the cross product of those two vectors, right? So what we'll do, we'll multiply that, we'll find the cross product AB vector cross AC vector. How to find? Determinate. First row will be I cap, J cap, K cap. Then elements of first AB vector is, now that is 1, 2 and 3. AC vector is I is 0, J is 4 and K is 3. Right? We'll expand this. I cap into, delete first row, first column, 3 into 2 will be 6, 4 into 3 will be 12, this minus 12, minus J cap into, delete this and this, 3 into 1 will be 3, minus 0, clear, plus K cap into, delete this, 4 into 1 will be 4. So this is equal to 6 minus 12 will be minus 6 I cap minus 3 J cap plus 4 K cap. This will give you a AB vector cross C vector, sorry, AC vector, right? AB vector cross AC vector. So now area of a triangle is half into magnitude of AB vector cross AC vector. Now first find the magnitude of this. What will be the magnitude of this? Magnitude of AB vector cross AC vector is equal to root of, see, 6 square will be 36 plus 3 square is 9 plus 4 square is 16, right? So that is 6 plus 9 is 45, 45 plus 16 will be 61, right? So this is, sorry, root 61. So root 61. So just substitute here. So this is equal to half into magnitude of AB vector cross AC vector will be root 61 square units. Clear? Square units. So this is root 61 divided by 2 is the area of a given triangle. And the area of a parallelogram whose adjacent sides are determined by, here directly A vector and B vector is given. So our work is easy, right? So if it is A vector and B vector is not given, if it is given in the points, then there also it should be adjacent sides. Is it clear? It should be like this. If I consider A, B, C, then AB vector and AC vector. Is it clear? So like this you have to find. So here directly it is given. So directly we will write area of a parallelogram is given by magnitude of A vector cross B vector. So this is the area of a parallelogram. First we'll find A vector cross B vector. What it will be? Magnitude of I cap, J cap, K cap. Write the coefficients 1, -1 and 3. There it is 2, -7 and 1. Right? We'll expand this. I cap into delete -1 it will be -1. So this is minus into minus will be plus 21 minus J cap. Okay, delete this 1 minus 6, right? Plus K cap into, so this -7 and plus 2. Then you simplify, okay? Simplify and find the magnitude of that. Root of square of this value, square of this and square of this, so that you will get the area of a parallel. Complete this, simple it is. Read the question carefully and try to understand it. If a unit vector A vector, so unit vector A vector is given, right? So the obviously the magnitude of A vector will be equal to 1, which makes an angle pi by 3 with I and pi by 4 with J cap, okay, and acute angle with K cap. Then find theta and components of A vector. Okay, you have to find the angle theta. Two angles are given with the, this I cap it makes pi by 3, with J it makes pi by 4, with K you have to find and the components of that. Let us consider, let A1, A2, A3 are the components of A vector. Okay, these are the components of A vector. That means A vector is equal to A1 I cap plus A2 J cap plus A3 K cap. In the beginning, you have studied about the direction cosines, right? What is meant by direction cosines? L, M, N, right? So this will be now cos alpha. Here alpha angle with the, which one? I. This is next cos beta with the direction of J. Which axis? This is with the x-axis and this will be with the y-axis and this will be with the z-axis. So here it is given, so we'll use this formula, and cos alpha is equal to A1 divided by magnitude of A vector, right? Cos beta A2 by magnitude of A vector. Cos gamma will be A3 by magnitude of A vector. We'll use this formula to solve this. First let us consider cos alpha is equal to A1 by magnitude of A vector. So cos alpha, what is alpha? Angle with the x-axis, it is pi by 3. So this will be now cos pi by 3 is equal to A1 divided by magnitude of A vector 1, because it is given as a unit vector. So this is equal to 1. Cos pi by 3 is 1 by 2. So by this what we can write? A1 is equal to 1 by 2. I hope you are getting this. A1 is equal to 1 by 2. Similarly, cos beta is equal to A2 by magnitude of A vector. So with the y-axis, beta will be now pi by 4. So it is cos pi by 4 is equal to A2 divided by magnitude of A vector will be 1. So by this what we can write? A2 is equal to cos pi by 4, 1 by root 2. But to find A3, the angle is not given, right? Before that we need to find the angle. First we will write this. Cos gamma is equal to, this is A3 divided by magnitude of A vector. See, here it is given that acute angle theta, right? So we will consider this gamma as theta. Cos theta is equal to A3 by magnitude of A vector. So by this I can write A3 is equal to cos theta. If you find the value of theta angle, then obviously you can find the component. So here one more thing, magnitude of A vector is equal to what? See here, magnitude of A vector is equal to 1. So by this we can write magnitude of A vector. Square root of this plus square of this plus square of this should be equal to 1. Right? So we will write this as root of A1 is 1 by 2. Is it clear? Magnitude is nothing but components or the coefficient of I, J, K we have to consider. So 1 by 2 plus 1 by root 2 whole square plus remaining cos square theta is equal to 1. Right? We'll square on both sides. So this will be 1 by 4 plus 1 by 2 plus cos square theta is equal to 1. So this is now, if you take the LCM 4, so this is 2 plus 1 will be 3 by 4 plus cos square theta is equal to 1. So cos square theta is equal to 1 minus 3 by 4. So that is 4 minus 1 will be, minus 3 by 4 will be 1 by 4. So cos theta is equal to plus or minus root of 1 by 4. I can write, so this is as 1 by 2, plus or minus, but it is considered as angle is, positive, right? So this is considered as acute angle. So we will consider cos theta is equal to 1 by 2. Now what is the possible angle? Cos theta is 1 by 2 means theta will be equal to pi by 3. Clear? So theta is equal to, so final answer should be the very acute angle theta is equal to pi by 3, and the components are a1 is 1 by 2, a2 is 1 by root 2, right? And a3 is equal to cos theta. So cos theta value will be equal to cos pi by 3 is 1 by 2. So this is the answer. See this simple one, within 2 steps we will get the answer. A vector minus b vector cross a vector plus b vector. Will multiply, it will be a vector cross a vector, right? And plus a vector cross b vector. A vector cross b vector, we have multiplied by a vector, will multiply minus b vector. So minus b vector cross a vector, so here b vector cross a vector minus b vector cross b vector. Clear? A vector cross a vector cross b vector. In between sign is plus. Minus b vector cross a vector, minus into plus will be minus b vector cross b vector. What is meant by a vector cross a vector? Angle between them is 0. So this is equal to 0. Plus here a vector cross b vector. Here b vector cross a vector, it can be written as minus of minus a vector cross b vector. Yes. So this is equal to b vector cross b vector will be 0. So by this is also 0. A vector cross b vector minus into minus will be plus a vector cross b vector will be equal to 2 a vector cross b vector. Find lambda and mu if cross product of this is equal to 0 vector is given. First we will find the cross product of that. So it will be, better you write that once, then you write this I cap, j cap, k cap. You need to find the values of lambda and mu. So this will be now 2, 6 and this is 27. That will be 1 lambda and this is mu is equal to 0 vector. 0 vector I can write as 0 I cap plus 0 j cap plus 0 k cap, right? 0 vector can be written like this. Now expand this I cap into, delete first row first column, so this will be now 6 mu minus 27 lambda minus j into, delete this and this, so this will be now 2 mu minus 27 last plus k cap into, delete this, 2 lambda minus 6 is equal to 0 vector. 0 vector is nothing but 0 I cap, 0 j cap and 0 k cap. When two vectors are equal, their components should be equal. If their components are equal, then only we can say that two vectors are equal, right? In the beginning when you have studied. So this is now 0 vector is nothing but 0 I cap, 0 j cap and 0 k cap. Now we will compare the components of I cap, j cap and k cap. Is it clear? Coefficient of them. So this is now what I can write, 6 mu minus 27 lambda is equal to, here coefficient is 0. Another one is here 2 mu minus 27 is equal to 0. One more 2 lambda minus 6 is equal to 0. By this what we can write, no need to solve this, right? So 2 mu minus 27, so mu will be equal to 27 divided by 2. So this is mu. Now what about lambda? Lambda is equal to 6 divided by 2 will be equal to 3. Is it clear? Important one. Mu is equal to 27 by 2 and lambda is equal to 3. So this should be the answer. 2 marks problem. See this. Given that a vector dot b vector is equal to 0 and a vector cross b vector is equal to 0. What can we conclude about a vector and b vector? Can you say? When this dot product will be equal to 0. Either a vector equal to 0 or b vector should be equal to 0 or those two be perpendicular, right? Whenever they are perpendicular, we can say that dot product is equal to 0. This is the one condition. For this, when it will be either a vector should be equal to 0 or b vector should be equal to 0 or a vector should be parallel to b vector. right? Which condition here we can take? Here both are equal to 0. So we can't take A vector is parallel to B vector. If I consider that this will be 0, but this is not equal to 0, right? If I consider parallel. If I consider perpendicular, now this will be 0, but this is not equal to 0, right? I hope you are getting this. So what we can do, either A vector should be equal to 0 or B vector should be equal to 0. Only two conditions are possible. Either A vector equal to 0 or B vector is equal to 0.